Hi, I wanted to explain what we'll be doing for the next week's in-class assignment. I'll be passing out a few worksheets, and this will be the first one. I'll start by explaining what's over here on this side of the screen, and then talk about what's over here. So I said this will probably be the first page of the worksheet. This is supposed to be a spreadsheet, like an Excel spreadsheet. What I want you to do is to um, think of three things that you want to collect data from. It could be either three houses, um, three cities, or three people. And if you decide to, well, you're not actually going to be collecting data, but you're going to pretend like you're collecting data and then put some made up values in here. You're just going to make up a spreadsheet. So if you're collecting data from houses, it would be house one, house two, house three. You could just label them that way. Or if you're collecting data from cities, you could just put city one, city two, city three. That's fine. And you also need to think of your variables, your variable names, which are the column titles. So if I'm a student and I decided to put house one, house two, house three as my row titles, my variables could be something like price, location, number of floors, number of bedrooms, and I would put those as my column titles. Those would be those four column titles would be my four variables. And after you put your row titles and your column titles, um, I want you to make up some data values inside here. So if you put price right here for the price of three houses, you would make up a number for the price of the first house, the price of the second house, and the price of the third house. If this is location, this I would make up a location for the first house, maybe Concord. I'd make up a location for the second house, maybe Hayward, and then make up another location. And I just make up 12 data values. Um, you can make up any values you want as long as they make sense. For example, um, if this is number of floors, um, it wouldn't make sense to put 1,000, 2,000, or 1,500 as the values for a number of floors because those aren't possible. So just make up some values that make sense. Um, Underneath the title of each of your variables, well, you'll say what type of variable it is. So you'll put the name of your first variable here, and then under it you'll write, well, if it's a qualitative nominal variable, you would write qualitative nominal. Here you would write the name of your second variable. If it's quantitative discrete, you would write quantitative discrete. So you'll have the names of the four variables, and then under each one, the type of variable that it is. So each one will be the variable name, and then the type of variable. And you'll do that 4 times, one for each column. Up here, you'll write a word inside of here, and the word that you'll write in here is supposed to be what these four column titles are called. There's a name for them. It's one of the main terms that we covered in class, and you'll put that in here. There's also a term for the 3 row titles that we covered in class. You'll put that term in here. Just write it in here. There's also a name for each of the 12 values that are inside of here, and you'll write that name in here. It's just the three different terms that we covered in class last week. Once you get over here, I'll give you an example of a variable, maybe something like account balance, and then I'll have a number line like this one. These are some different possible values: 1 cent, 2 cent, 3 cents. What I want you to do is to try to make a diagram here to decide if it's a discrete or a continuous quantitative variable. Remember that the two types of quantitative are discrete and continuous. So what you need to do is mark off each possible value in green. These are all the possible numbers that an account balance could be. It could possibly be 1, 2, 3, 4, 5 cents, but nothing in between is possible. I don't think an account balance can be 0.015 because I don't think half a cent is possible for account balance. So here I would put a red. I would color this in red to show that anything in here is not a possible number. I would also color this in red to show that any number between 2 and 3 cents is not possible. It can't, for example, it can't be 0.027. So these red areas are the gaps where no values can be found. And you'll just keep doing this. When you create your spreadsheet over here, what I want you to do is to try to come up with one example of each type of variable. So make one of them qualitative nominal, one qualitative ordinal, one quantitative discrete, one quantitative continuous. So overall, 2 of them will be qualitative, 2 of them will be quantitative. I want you to write the name of your first quantitative variable over here. So if my 2 quantitative variables here were height and age, I would put height here, and then age would come later. So if my first quantitative variable right here is height, I would write height here. If my second one is age, I would put age right here. And then what I want you to do is, for each one of them, is to think about whether the variable is discrete or continuous. So actually, what if my first quantitative variable over here was number of siblings? What I would want you to do is to try to think of what the possible values are for number of siblings, and then mark them here. Try to start with the first possible value, then go up to the next possible value, and then try to think of what the next possible value is. And then after you do that, mark off those possible values in green like this. And if nothing in between is possible, if you realize that nothing in between is possible, like you can't have 1.5 siblings, mark that area off in red. So if it's marked in red, it means that nothing in here is possible. Or if I was doing shoe sizes, I might pick a number to start with, like 10, and then move up and then go up. And for shoe sizes, I would put 10, 10.5, 11, 11.5, 12, and then keep going up that way, because you can have 0.5 at the end of a shoe size. But I would still be marking off values. I would still be marking off these areas in red, because if it's a shoe size of 10, 10.5, 11, 11.5, 12, nothing in between is possible. Shoe size can't be 10.2 in here. So it'd still have these red areas marked off where no values can be found. What if my last variable here was height? Height is a continuous variable. So if it's a continuous variable, what I want you to do is, so my variable name goes right here. Think of some tick marks that make sense. For example, maybe for heights, I would start at 50 inches, 51 inches, 52 inches, and then keep going up. But what I would do is, when it's continuous, mark off the entire number line in green to show that up here, so up here, everything in green was a possible value. So the green marks are the possible spots where a value can be found, and everything in red was not a possible area. Here, since any number is possible, it just all becomes green. There's no red areas where a value can't be found. So if it's continuous, it's like this. There are anything is possible between the beginning and end of the number line. And then that would finish this page. What I want you to do next is I'll have you doing some simulations with random sampling. I'll show you the first page. So I'll give you this diagram here with these population members. Each stick figure is meant to be a student in a certain class. So we could imagine that this is maybe 15 students who are all in a class together. It's just a small population. And what this is showing is the exam score of each student. This student got a 70 on the exam. This student got a 71. These two students got a 72, and so on. I want you to select random samples 3 at a time. So you'll select a random sample of 3, and then another random sample of 3 over and over. And I'll show you how you can do that. I set this up in Excel. I'll make this Excel file available to you in the lab. This column A, has all of the exam scores. This column over here in red are actually random numbers. And I'll show you what their purpose is. If you highlight, well, first I need to show you one thing that you'll need to do first. You'll need to find the mean of the population. You could find the population mean by adding the 15 values and dividing by 15. Or you could just say equals average in Excel, highlight all the scores of all 15 people in the population, close the parentheses. So it's the average from A1 down to A15. Close the parentheses and press enter, and it gives you the average score of all 15 population members. The mean or average of all population members is the population mean. So this is the mean of our population of 15 people. I want you to label the population mean. So it came out to 74, which is right here at the center. Say mu equals 74, the population mean. And I'll also have you write it in words. Just population mean. You could do it like this. You could label it like this. And then after you do this, I want you to show your work for the population mean. So just write out the values of all 15 population members like this. 70 plus 71. So I would accept something like this to show your work. Add the numbers like this. Maybe write out the numbers in a column. Show what they add up to. It's 5625. Show the dividing step. If it's a mean, you divide by the number of numbers. So we're dividing by 15. and the mean and average mean the same thing, so sometimes in the video I say mean or sometimes I say average, but they mean the same thing. So the mean is 74, the population mean. Okay, now we can get the mean of our first sample of 3 people. This is what you'll need to do. You go up here, highlight both columns. Well, first what you'll need to do is type in an equal sign right here and a column over here. Highlight the first column, the first data value, press enter, highlight it, drag it down to the 3rd row, it selects the first 3. Right here type in equals average, highlight the 3 values, close the parentheses and press enter, and you actually get the mean of all 3 values. You get what you would have calculated if you had just added them and divided by 3. So what you can do, highlight both columns, the values and the random numbers, go up to sort up here, data, click on data, then click on sort. Then click on sort values, no, sort by column B, the random numbers, from smallest to largest. It sorts the random number column, but what it does is it also randomizes the order of the data values. So now your first 3 values are actually a random sample of 3 out of the 15, and those 3 values are in here. This is your first random sample of 3, and it automatically calculates the mean of the sample. Your first sample mean is 71.33. Now I said I want you to calculate to show work for your first sample mean. So this would be 70 plus, my values were 71, 70, 73. That was my first sample. So 70 plus 71 plus 73. Just add them. I think they add up to 200, 204 divided by 3 to get the sample mean is came out to 71.33. Put that over here as your first sample mean. And then go to this sample mean column and make a tick mark for your where your first sample mean is 71.33. So that's about a little bit above 71. A sample mean is an X bar. That's the symbol for sample mean. The Greek letter mu, which looks like a mu, is population mean. X bar is sample mean. So put an X bar right there. What I'll have you do next is go back to Excel, resort these, go to data at the top, sort the values by column B, smallest to largest again. It'll put, once again, the first 3 values go into here automatically. You automatically get the mean of the 3. So my next sample mean is 73.33. But what I actually want you to be doing for your first, for the first 5 samples that you take, I want you to mark off the people who were selected. So my first sample was 70, 71, 73. Put a 1 right there, because the 71 was selected. Put a 1 here. It means that they're a member of sample 1. Put a 1 next to one of the 73s. It doesn't matter which one. This shows that this is the members of sample 1. For my second sample is 74, 72, 74. So just put a 2 next to two 74s. Those people were selected, and then put a 2 next to one of the 72s, just to show we got a 72 and two 74s inside sample 2. I'll have you do this for the first 5 samples that you select, and then you can stop numbering them up here. So also, well, I said you need to show your work for the first sample, the sample mean, and then put it up here. But after that, just use Excel. So the next sample mean is 73.33. Now I'm going to get my third sample, resort again. This is my new sample of 3 values. These 3 people, their mean is 74.67, rounded. So I'm going to put 74.67 in here as the third sample mean, and then make the X bar I'll also have you number these: the mean of sample 1, the mean of sample 2, the mean of sample 3. I said I want you to number the people that were selected. So the third sample was 75, 71, 78. There's only one 71, so it has to be this one. Put a 3 here somewhere. Put a 3 here. Now, do it again. So each time, sort the values. Get the 3 numbers in the sample. Mark them off. 75, 72, 76. I marked off 3 people in sample 4. Show where they are. Once I do that, I'll put the sample mean over here. It's 74.33. That's about right here. If it's about the same number, stack it above the other one. Actually, these are really close. But if you can, try to fit it in. This. If you get the same exact number twice, then you would stack a second X bar above the first one. And then each time, just take a new random sample of 3. With Excel, by sorting, once you get your random sample, mark off the 3 values inside of here, put the sample mean right here, and then put an X bar right here, and just keep repeating that over and over. And then I might give you about 3 different pages of this. Each time it'll be the same work, but just with a different type of population. Maybe on the second worksheet, the numbers will be more spread out. Like maybe instead of 70 to 78, it'll go from 20 to 90, or something like that. Also, on this page right here, I would want you to do this 20 times. So 20 different random samples, all the way up to X bar 20. And like I said, you're just doing the same thing over and over. get the sample of 3 people, mark them off up here, and then put the sample mean here, and then put the X bar there, and then move on to the next sample. I said you'll only have to be marking them in here for the first 5 samples because it'll just end up being too much numbers in here. After this, I might also, I said I might change the number line on the next worksheet, but I'll probably also have you do it with a different sample size where instead of doing it over and over again with samples of 3, you'll be using a sample size of 10. So you'll be getting a random sample of 10, another random sample of 10, and another of 10. If I said to do it with samples of 10, you would just you'd have to highlight, you'd have to do the same thing we did here, equals first value. But now you'll be dragging it down to row 10 to get the first 10 values. You'll get equals average. Type in equals average and just do the same thing over and over again. Sort the numbers and it'll recalculate. After you do some work like this, I'm going to give you a sheet where you sample from 2 populations. So each time you'll take a random sample from here and a random sample from here and get the mean of the sample from population 1 and the mean of the sample from population 2. I'll show you some examples. First, I want you to calculate the mean of the people in population 1 and the mean of the people in population 2. So once again, this could just be the exam scores of 15 people in one class and the mean exam scores of 15 people in a different class. So maybe these 2 populations are just different classrooms. And maybe we're interested in sampling both populations to try to get an idea of which class did better on the exam. We can see obviously that they performed equally, but maybe as a researcher, we just want to look at whether one class did better than the other. I want you to calculate the population means like you did before. So add these 15 numbers and divide by 15. You'll get the mean of this population. If I did it, it would be 74. Put population mean right there. Do the same thing here. Add the 15 numbers, divide by 15. You get the mean of population 2. What I need you to do is I'll have a worksheet like an Excel sheet like this. These are the values from population 1. These are the values from population 2. If I tell you to use a sample size of 3, you'll have to go equals, highlight this number, the first one in population 1, drag it down to the 3rd row, highlights the first 3 values. Over here somewhere, type in equals, highlight the first value in population 2, press enter, drag it down to get the first 3 values in population 2. Type in equals average, highlight these to get the mean of sample 1. Type in equals average, highlight these 3 numbers to get the mean of sample 2. So sample 1 comes from population 1, sample 2 comes from population 2. This is the mean of sample 1 and the mean of sample 2. This is the mean of these 3 numbers, that's the mean of these 3 numbers. Now, I said we want to take a random sample of 3 people from here and a random sample of 3 people from here. So I have to shuffle. So I can go to data, sort the values by column B is the random numbers, so it has to be column B again. Smallest, largest. It automatically takes a sample and calculates its mean. Do the same thing over here. Highlight these two. Now instead of these two columns, it's these two columns. Sort by the random number column. So this time the random number column is column E. It's in red. So now I took a random sample of 3 people from population 2 and got the mean of this sample. So the sample means are actually the same. So what I would do is, well, first I need to mark off some numbers. So in sample 1, the 3 numbers were 76, 72, 73. I need to mark those off. So now 76, 72, 73. Mark them off in ones. This is sample 1. Mark off sample 2. It was also 76, 72, 73. Just pick one of these people. Pick one of these people. Pick one of these people. These are the 3 people that ended up in the sample. These 3 people ended up in this sample. Put the 2 sample means over here, so you could round them to 2 decimal places. This is the mean of sample 1 from population 1. Over here, put the mean of sample 2 from population 2 in this column. Over here, I want you to put in a third column the sample mean difference. That's just what you get by subtracting the first sample mean by the second sample mean. This minus this equals 0. So our first sample mean difference is actually 0. Because they're equal, there's no difference. Once I do this, mark off x bar 1 for the mean of the first sample from population 1. Mark off x bar 2. I'm sorry, it's actually x bar 1 again, because it's the mean of the first sample from population 2. Put a difference. This is the first sample mean difference. Put a d above 0 for that sample mean difference. Now just repeat again. Go back here, resort, sort by column B, it should reshuffle the numbers. Sorry, now it works. I shuffled this and I shuffled this, and this time I got these 3 and these 3 as my 2 samples. The 2 sample means are 73 and 75. So these values in sample 1 are 72, 73, and 74. Just put a 2 here. 2, 72, 73. Pick one of the 74s. The sample 2 was 72, 76, 77. So now it's the second sample from population 1 and the second sample from population 2. Now I'll put the 2 sample means in here. The mean of the first sample over here was 73. The mean of the second sample was 75. These are from sample 1, sample 1, sample 2. The difference between the 2 samples, if you subtract this by this, you get negative 2. So our next sample, so now we'll put an x bar for 73. It's going to be a 2 because it's the second sample from population 1. This is our second sample mean from population 2. So it's x bar 2 over here. The difference between them is negative 2. That's our second d. You could also label these D1, D2, and just keep repeating this about 20 times. And then, or however many times I decide that we should be doing it, depending on how much room we have. I'll probably have you doing this on at least a couple of different worksheets with at least 2 different situations, because I could change the sample size, or I could make it so that these numbers aren't the same as these numbers. This is what I wanted you to do right here. I'll probably have a page like this. I'm going to have you make up 3 different columns of data. For the first one, just make it so that they're all the same number. Maybe 10, 10, 10, and 10. I'm going to have you, well, first, you need to, I'm going to have you calculate the mean absolute deviation, variance, and standard deviation. So what you need to do first is get the mean. Add these values and divide by 4 to get, and then that'll give you the mean. Make a column in which you just have the mean. The mean of these 4 numbers would be 10, so I'm putting 10 here. If all the numbers are the same, the mean is just that number. What you'll need to do next is subtract each number by the mean. Once you do that, the answers are called deviations. When you subtract each data value by the mean, you get deviations. And then we need a column of absolute deviations. So it's just the absolute value of each of these 4 deviations. The absolute value of 0 is just 0. To get the mean absolute deviation, you just get the mean of the absolute deviations. So I would add them and divide the total by the number of absolute deviations, which there's 4 of them, so I divide by 4, and I get 0. So that's the mean absolute deviation. Just the mean. All it is the mean of the absolute deviations. Its abbreviation is MAD. So I could say MAD equals 0. I now need a column of squared deviations. So what I do now is, over here I was getting the absolute value of each of these deviations. Now I'm squaring each of these 4 deviations, which just means multiplying each deviation by itself. 0 times 0 is 0. 0 times 0 is 0 again. Once I get all 4 squared deviations, I get the variance, which is, the variance is just the mean of the squared deviations. So add them, since there's 4 numbers in the column, divide by 4. Comes out to 0. So the mean of the squared deviation column is the variance. The standard deviation is the third value, and that's just the square root of whatever the variance equals. So if the variance is 0, get the square root of 0, and that's your standard deviation. It's 0 again. All 3 of these values, MAD, variance, and standard deviation, all came out to 0. That's what always happens when the values are all the same and there's no spread. So what you need to do is put 10 in the center, make some other tick marks, I want you to put your starting number in the center and then put 4 x's for the 4 values. And like I said, an x bar is a mean, but an x is just a data value. So put 4 x's. And then what I want you to do next is take 2 of your numbers, pick any 2 numbers you want, subtract one of them by a certain number, and add the same number to the other value. So, for example, I could pick 2 values, subtract one of them by 2, add 2 to the other one, or subtract one of them by 3, add 3 to the other one. I just need to subtract one number by a certain number and add that number to one other value. Here's an example. I take 10, subtract 3, it goes to 7. I take my last 10, add 3, it goes up to 13. This just increases the spread a little bit. Now I want you to find these 3 values with this data set. So I had to calculate the mean of these 4 numbers. I had to add the 4 values and divide by 4 to my column of data. The mean of my 4 data values here was actually 10 again. If you add these 4 numbers and divide by 4, it'll come out to 10. So I put that mean of 10 in here. I subtracted each of my 4 data values by the mean. When you do that, each answer is called a deviation. Whenever you subtract a data value by the mean, the answer is a deviation. So here we have -3, 0, 0, +3. Now I have my deviation column. Now I need to make the absolute deviation column. An absolute value of a number is just the digit, and you leave off the sign. So if I leave off the negative sign, I get a 3. This is the absolute value of -3. The absolute value of 0 is just 0. Here, just take off the plus sign, and it's 3. Those are the absolute deviations. So what I need to do now is calculate the mean of the absolute deviations. So add them, divide by, there's 4 of them, so divide by 4. And I get 1.5 is my MAD. The MAD is the mean absolute deviation, which is just the mean of the absolute deviations. Now I need to get the squared deviations. To do that, I need to square each deviation. So multiply each deviation by itself. -3 times -3 is 9. The negatives cancel out. 0 times 0 is 0. 3 times 3 is 9. Now I need the mean of the squared deviations. So add them, divide by 4. The mean of the squared deviations is 4.5, and the mean of the squared deviations is called the variance of the data. You can label it like this. The standard deviation is just the square root of the variance. Square root of 4.5 is 2.12 rounded. This is SD for standard deviation. So MAD, variance standard deviation data set 2. What I want you to do over here is make an X for each data value. Make the same tick marks. So 7 is the first value. 10, there's 2 10s. Over here, we have a 13. So what I'll have you do is, well, I want you to label the mean of the 4 values. Here. Draw a line here, connecting the value to where the mean is. This is 7. Try to look at what the deviation look at 7 right here, the data value, and find its deviation, absolute deviation, and squared deviation. Put them here, above this line. So, -3, 3, and 9. Deviation, absolute deviation, squared deviation. So, what this is saying is that 7 has a deviation of -3. It's 3 below. Makes 7. What that's saying is that 7 is 3 below the mean of 10. That's where the negative sign comes from. It means 3 below. What this is saying, the absolute deviation, is just 7 is 3 away from the mean of 10. The absolute deviation is just the distance from the data value to the mean. The squared deviation is just the squared distance from the data value to the mean. So you take the distance of 3 from 7 to 10, square it, and you get 9, which is the squared deviation. This is 13. So right here, go to 13, put the deviation, the absolute deviation, and the squared deviation, which is 9. For the final one, I'll have you take the other 2 values that you haven't changed yet. So I haven't changed these yet, and subtract one number by something, add the same number to the other one. So what if I decide to do 3 again? Subtract by 3. This goes down to 7. Add 3 to that. It's 13. So once again, I'm just taking the number, subtracting it by something, taking the other number, adding it by the same number. 10 minus 3, 10 plus 3. That gives me these 2 numbers here. Now my x's will be, if I did that, my mean would still be 10 right here. Okay, so I finished the work with my third set of numbers. I want to go back over here for a second. So I said that these three numbers that I put here are actually the deviation, absolute deviation, and squared deviation of 7. That's what these three numbers are. These three numbers are the deviation, absolute deviation, and squared deviation of 13. I'm actually not showing any numbers for 10 and 10. I'm not showing their deviations on here because these two numbers both have deviations of 0. You can see that in here. There's also no space for me to label them. So all I did, the labeling was for 7 and 13. Over here, I took my new set of 4 numbers. I calculated the 3 values the same way. Now I can actually draw a number line connecting each value to the mean of 10, like this. And I can start with the first 7, put the deviation, absolute deviation is 3, squared deviation is 9, put that there. Go to the second 7, put its deviation first, its absolute deviation, and its squared deviation of 9. Do 13. 13 has 3, 3, and 9. Well, plus 3. The deviation says plus 3 to show that it's 3 above the mean. So now I'm actually doing this for all. I'm labeling it for all 4 data values. And then that finishes this work. So you made up a set of numbers that were all the same. You did this right here. You calculated the 3 values. They all came out to 0 because the data has no spread. Here, I took the first number, subtracted by 3. Then the last number, added 3. I put my 4 data values as x's again, 7, 10, 10, 13, and I did the labeling. I labeled the deviation, absolute deviation, and squared deviation for 7 right here, and for 13. And here I did. Here, none of the values were equal to the mean. None of them had deviations of 0. So I actually could do this labeling. I could actually label the deviations for all 4 numbers, like I did here. If we have time, I might also give you something like this right here, where I would say, for data set 3, you're making up a set of numbers, but try to make it look like it has a normal distribution. Just try to start by just trying to make some x's that look like a normal distribution. Just doesn't have to be perfectly normal, but just try to do something like this. Then up here, write them out as numbers. So 6. If these were my x's, it would be 6, 7, 7, 8, 8. Just write them out as a column. And then underneath here, label the mean, median, and mode with an arrow pointing to each of them. They're actually all the same if it's normal or symmetrical, so I could just put mean, median, mode, label them all at the same time. Over here, start with making some x's, but try to make it so that it's a little bit positively skewed. Positively skewed means it peaks near the left end and then trails off toward the right. So, and draw a curve around each one. So this, and then if it's positively skewed, show that it peaks at the left end and then trails off toward the right like that. Over here, oh, and then write out your values as a column up here. Over here, do the same thing, but try to make it something called a negative skewness, where it peaks at the right end, near the right end, and then trails off to the left. Just make up something that looks like this, something like this. Write the numbers up here, make a curve around it, and try to make this one more highly skewed than this one. The same shape as over here, but more dramatic. And try to make the same type of shape over here, but just more dramatic, a more dramatic skewness. And just do the same thing over again. And just find the median, the mean, median, and mode, and then make arrows to label them. Just write like mean, median, mode under here to whatever they equal.